All right. Welcome back, everybody, to the last day of the guided application program. Uh, it's been a short journey, 3 weeks. A lot of you guys came here with some knowledge of Python. Some of you guys having no idea. Today will be the last culminating mini project for the program itself, where we get to wrap it up with everything that we have learned up to this point, and kind of put it into play, right? Yesterday we finished the mini project involving the Powerball. Today we're going to move on to the last and final lesson of the course, which is the mini project 3. This is a typo. Um, Mini project 3, right? Where we're going to be using what is this, poker, right, as a learning example. Yesterday, you guys were able to see how we can use Python code to kind of recreate the process of the Powerball itself, right? We were able to create different functions. One function that would generate some kind of ticket that would be like the winning roll or the winning ticket for the Powerball itself. We created a different function that would generate the player's ticket, what to simulate them buying it from the store with their lucky numbers, and then checking whether they won or not. You've seen some small examples of this when we were going through the course with like the guessing a number game, right? So you can do small little programs here to practice all the tools that you have been learning throughout the course, and to make it kind of interactive and fun. Uh, and using those same principles, we're going to do the same thing but with poker. Now, personally, I'm not much of a poker fan either. I actually, I didn't build these curriculums. I'm assuming the creator of the project itself was probably some kind of a fan of poker and the Powerball. But I don't, I'm not much of a gambler. Um, so I know enough to play, but not enough to like be good at it, if that makes sense, right? Um, and I know it's not that popular with so many people, but we're gonna talk about it and learn a little bit more about poker, right? So for this mini project, we're gonna build a poker hand evaluator, right? What we mean by that, a poker hand, we mean the cards that were dealt to people, right? For those who are not familiar with poker, it is a card game played with a standard card deck of 52 cards, right? Your standard, typical, classic deck of cards that you see magicians use, right? Poker, a game that comes in various forms, is a card game played with two or more people. For today's example, just simulate the game of two players, right? We don't want to add too much complexity to this. We want something that can at least work. The maximum player count is determined by the type of poker game. The way the card games are dealt can vary wildly, but the base concept is the same, right? So a player wants to get the best 5 card hand possible, or essentially the best combination of 5 cards, right? And win the chips in the middle that have been bet. Now, can it be any combination? Not exactly, right? There actually is a ranking here of different hands, and I do not believe I can increase that. So give me a second. Let me see if we can find it real quick uh, on Google and talk about the hands. Right. So poker car or hand rankings. Let's look at something a little bit bigger. And this looks like the same picture that we have here on the curriculum. But this is, a quick, easy fix. I hate ads. But the best possible hand, specifically in the text hold'em, right, is your royal flush, right, which is your the king, the queen, and the jack with the ace as well as the 10. Uh, right. So the combination of 10, jack, queen, king, and ace, all of the same suit, right? And then they go from the best possible hand to the least possible hand, right? Royal flush being the best, straight flush, four of kinds, so on and so forth. and I believe there's 9 combinations. So we have 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10. Now, if I was writing this program and I wanted to get or to know like how would I determine what is the best possible solutions? I might want to rank these, right? If it's this kind of combination, I might give this a value of 10. This might be a value of 9, value of 8, so on and so forth. And then I can use those values to kind of represent which one is better, right? The higher value I have, the better my card is. The stronger of a combination. So if you guys cannot see the picture in the curriculum, a quick Google search, as you just saw, will lead you to a page very similar to this for the poker hand rankings. Right. So there are many more factors that drive poker gameplay, such as bluffing, but there's always one final comparison that determines a winner of a hand: the showdown, right? The showdown is where the players that have not voted compare their hands to each other to find a winner. So there's obviously some things that we can't exactly replicate on the program, which is like, having the players actually uh, go through the game and then look at each other and say whether they want to call or raise. Call being whether they want to, stay in the game and but not increase the pool, and then either raise how much money they're betting on their hand. Right, we're not gonna make it too complex. Uh, what this program that we're going to make should be fairly simple. To keep it very simple, what should happen is we want to create a couple functions, right? Uh, One function should be getting the hand rankings, right? So we should be able to get the ranking of a hand. Um, and let's kind of do some pseudo code here. We should have a function that gets the ranking, or in other words, like the value of a hand, right? Hand, in other words, card combination, right? Uh, and once again, how many cards in a hand or in a combination? We have 5, right? So this hand slash card combination will be a combination of 5 different cards that will be dealt to the player, right? And we should make a function that's able to receive 5 different cards, and within this function, identify the hand ranking, right? Using the actual hand rankings that go into the game itself, right? So whether they have a royal flush, we should return the value of 10. Also with whatever actual cards they have, or something similar to that, right? If they have a full house, return the value of 7, right? And so on and so forth. So we should have some kind of function that's able to get the hand ranking of a hand, and that's probably gonna be the biggest legwork um of the thing itself, right? And then afterwards, we should be able to get 2 different hands, compare them, and maybe write a function that takes the values of 2 hands and determines who wins, right? Um, and it's a fairly simple program. Probably the hardest part is using the knowledge of the hand rankings to be able to determine how can I figure out what value should be returned. Um, but essentially, it's just going to be a poker hand evaluator. We're not recreating poker. We're just creating some kind of program that can evaluate the ranking of a card combination, right? So don't try to recreate the entire game itself. Once again, I reiterate, we are going to create a poker hand evaluator. Now, today it's going to be a little bit different. Um, Instead of me breaking you guys into your allotted times and give you 20 minutes to try the function, uh, in reality, these are just 2 straightforward functions. So what's going to happen is I'm going to break you guys up into teams. All right, for the first time, we're going to break into teams. And I'm thinking of doing teams of 2s. There might be one odd team. And then you guys will work with each other and collaborate to come up with a solution and code along. Now, the way that this is going to work, which is the best efficient manner, is if one person drives and the other person navigates, right? And what does that mean? Well, this is a concept that we call pair programming, right? We typically, especially for new developers, we make them do what's called pair programming, where we put them in pairs of twos, and we have the driver, which is the person who's going to be actively coding along. And I just lost somebody, immediately left. Okay, that's fine. Don't be discouraged, guys, about working with others. All right, don't be scared to the point that you will leave the class. It's okay, right? But we will pair up, right? One person will actively code. They will share the screen, encourage to share your screen, and you would be the one actually coding the problem. The navigator, Maury, that's what I'm talking about. Too late to leave, baby. That's right. We're in here. We're last day. Why would you leave last day, right? Like, come on, like get everything you can out of this. That second person, the navigator, your main role is to help guide, right? You're almost like the GPS. You shouldn't be telling the driver exactly what to do. No one wants to be a backseat driver, but you should watch them and kind of give guidance like, hey, like I saw that you maybe made a typo here, right? Or hey, I think this might not work because the way that you declared it. Or hey, just heads up, the variable you declared is being declared in the for loop, and that's not going to give you the intended functionality because it's going to reset every time you're trying to keep track of count, right? Something very similar to that, where you want to help navigate the person driving to ensure they don't get tunnel vision. Because a lot of times, and you see it when I code it along too, is we get very hyper focused on a very simple task that we fail to acknowledge everything else that's happening within our code, and it leads to us missing syntax errors. We missed a period, or like that one time when we were trying to format the phone numbers. I missed um, the fact that I was formatting or instantiating the dictionary within the for loop, and that was a very rookie mistake. And pair programming helps avoid these issues, right? You have someone driving and someone navigating. At the same time, you're learning from each other. So that's how we're gonna do it. Faith, are you new to the class? I've yet to see your naming here. Hello? Yes, okay. Awesome. Today is the last day of class. We are pretty ahead of the curriculum. I don't know if you've been keeping up with the videos, but since you just joined, a small recap. We are going to be doing a poker hand evaluator, right? So essentially, if you know anything about poker or not, you can still do a quick Google research, or your partner can fill you in. But in a sense, we are going to create a function that's going to take a hand combination of 5 cards, and we have to identify the value of that hand, and then create a separate function that can take 2 hands, run the previous function, and determine which hand wins. Right? We're going to break up into teams where we can work together and whatnot. Um, does anybody have any questions before I break open the breakout rooms and I break you off into teams? If someone cannot physically share their screen or code along, I need you to speak up now. So I know who not to pair it with who, right? There shouldn't be 2 people who are maybe like watching this on their phone and they can't code along. Okay, I'm assuming no one says they can't code along, so I'm assuming every single person here should be able to share their screens and do this actively, which is awesome. So we need to define the cars themselves. Nicholas, that is up to you, my friend. Right? However you want to reach this outcome, it does not matter. Just know, once again, the function should be able to take a card combination, right? So before I break you off, what is a card, right? If you, for example, if I told you describe to me, Nicholas, how would you describe this card right here? The one where my mouse is at. What is this card called?
That's the 10 of diamonds.
The 10 of diamonds, right? How can you describe that in code?
Words.
Okay, let's say it's a string. What's a very simple string that you can probably, a string combination to let you know immediately what something is? Maybe the string, the first string can be like the number, right? The 10, and the second part of the string could be what? The suit, which could be a D for diamond, right? We have D for diamond, S for spade, C for club. What else am I missing? H
H
for
for
heart,
hearts.
right? So you can make a string combination of like 10D. 10D, by reading this string, you know that this is a 10 of diamonds, right? Well, then you run into a problem. Well, what if it's 9 diamonds? That only has one number in the first part of the string, where 10 has two numbers, the 1 and 0. How would I split it up? However you want to do it. You want to do 09D for the 9 diamonds, however you want, right? So just know that you have to take in some kind of input that should, in a way, describe to you that what the hand is and what the cards has. How you code it out, that is up to you, my friend. If you want to verbally and explicitly and deliberately code out every hand, that's on you. But think of ways of how we can do this to make it more efficient, right? We could definitely do something like 1D, 2D, 3D, and by reading this, I could probably assume it's probably the 1 diamond, 2 diamond, 3 diamond. You can make values and you can make suits, right? The values themselves can be 1, 2, 3, 4, 5, 6, 7, 8, and I don't think we have ones actually. I think it starts at 2. It could be 2, 8, 9, 10, J, Q, and K. And to keep these in the same data types, maybe make these strings as well. Right? You can make values and then you can make suits, right? What would the suit be? Right? Suits can be uh, S for spades, D for diamonds, C for clubs, H for hearts. Right? And then randomly pull 5 cards for this to make each hand. However you want to make this, Nicholas. Um, but it's honestly the only limit is your imagination. Right? The only limit is your imagination. You guys have the tools to reach this outcome. Create a function that takes in a hand, or in other words, a combination of different cards, and can determine the value, and then tell you which one is greater, right? If I gave you 2 cards, right, the 10 of diamonds and the 2 of diamonds, could you take these 2 strings and tell me which one probably has a higher value? Right? Can you take in the string of 10D for 10 of diamonds and the string of 02D for the 2 of diamonds and tell me that one is higher value than the other one? Yeah, of course. Okay, now imagine doing that, but instead of just comparing 2 values, you're comparing a list of 5 different ones, right? That is not overcomplicated. There's definitely a way of doing this. If you can break it up into smaller problems, you can tackle it and get a solution, right? And that's honestly the trick here, Nicholas, right? And for the rest of you guys, a lot of problem solving in code is honestly breaking up a bigger problem into smaller problems. So you can compare one card to another. You can definitely compare 5 cards to 5 different cards, right? And think of it in that manner. Uh, how do I compare the cards, right? Maybe use a for loop where you have 2 different values. How do I know what's the value of a card? Maybe create something to check it against, right? Um, it's just breaking it up into smaller problems. But that's enough for me. I'm going to go ahead and pause the recording. All right, welcome back, guys. We're going to go ahead and talk through a little bit of the poker assignments. Nicholas, Vanessa, I'm in class. And I'm gonna start you guys off so you guys can kind of get an idea of how to approach this summit. I saw different ways that you guys were doing it, but there was a lot of confusion. So hopefully this little introduction is enough to kind of get you on the right track. So let me get this set up real quick. Oh, there we go. My bad. I was already sharing. Okay. So, as you guys saw earlier, before I broke you guys off, I created something very similar to this, where it's just values and suits. Now, these are constants, right? How do we know these are constants? Because they're in capital letters, right? These should probably not change, and these don't change. They're, the card faces and card values tend to be the same. So this is a good time of when you would use something like a constant in your code to ensure that everybody else is tracking that this is something that does not change. Uh, it will stay the same because this is what the cards are. Now, we mentioned about creating a function that gets the ranking slash value of a hand or card combination, and that card combination is a combination of 5 different cards. So to kind of test this out, I'm going to go ahead and create a variable that I can use to test out, and I'm going to call it hand1, and I'm going to make this to be a royal flush, right? Royal flush. And as we saw from the example, a royal flush is the best possible hand in Texas Hold'em. The combination of is a 10, Jack, Queen, King, and Ace, all of the same suit. So I'm gonna say T for 10 of hearts. And I use T instead of the 1-0 to make it easier if I wanted to grab index 0 to be the number or essentially the value. Uh, it makes it easier, right? Where everything else is a single character. 10 was the only weird one out where it had the 1-0. So I used T instead of the 1-0. And then we're gonna say the Jack of Hearts, followed by the Queen of Hearts, followed by the K of Hearts, and the Ace of Hearts. All right, so this is my hand that I'm gonna be passing in to my function, right? My hand combination right here. And now let's go ahead and define this function. This function is going to be called um, define handle maybe or determine handle card ranking or determine hand ranking. And it's going to take in a hand, right? And this hand argument is essentially this right here. It's going to take in some kind of hand combination and determine what it is. Now, to determine what it is, I need to know uh, the different combinations that I could possibly get. And I saw a couple of things that you guys did. I saw a bunch of if or else statements. And there's probably a much more efficient way of doing it. And I think the much more efficient way is to get what my combination is, split up the suits from the values, and then maybe make some separate functions that will determine one or the other, right? So let's actually get what values we have. So we'll create a variable in here called suit counts to count how many of the same suits we have. And we'll make it a dictionary. And we also want to know what the value count is, right? So the suit count is going to count how many times the heart appears. If there is a spade, how many times the spade appears. If there is a club, how many times the club appears, right? So in essence, this should look something very similar to like this, where the key will be the suit, and the value will be how many times it appears, right? If we had 3 hearts and maybe 2 spades, this would look like H with a value of 3 and S for spade with a value of 2, right? So our suit count will track how many of each suit we have in our hand combination, right? And let me set this as an example with some commented out stuff here. So you can see what the example should look like. Example, right? And our value count, this one's a little interesting. We want to count how many times, or honestly, what what card we are getting, right? Um, so because we can get the two of hearts, right? We can get the two of hearts and the two of spades. So we probably want to figure out how many times it appears, right? That number. And it'll look something like this, where how many times the 6 appears, or how many times the 8 appears, or the 9, because they can appear up to 4 times. It'll probably look something like this, where uh the string 4 appears twice, and maybe we got the 7 appeared once, and we got 9 that appeared 3 times, right? Something like this. This could be the example. Oh, let me remove this. So essentially, I have these dictionaries here that are going to allow me to keep track of what is actually in my hand. So I'm going to want to loop through my hand and split the strings and categorize them, right? So I'm going to say for, card, and hand. And then from here, I'm going to grab the suits, and I want to grab the value, right? So right here, this is a 10 of hearts. So when I loop through and grab this card, I want to grab what value it is. The value is 10, and then the suit is going to be the 8. So I want to grab one and the other. So we'll say suit is equal to card index 1, and the value is going to be equal to card index 0, right? Because all these cards here are a string of 2 different characters. The first character is the value, the second character is the suit. And once I do that, I'm going to say if the value, right? If the value, whether it's the 10, the jack, a 5 or a 6, if the value is not in my value count dictionary, then I want to add it. All right, so I'm going to call it dictionary. I'm going to set the value of the key, and I'm going to add a starting counter of 1, right? Because if it's not in there, that means I'm about to add it in here, and I want to keep track of the fact that I've already encountered it once. But if it isn't there, I need to increase the count by 1, right? So the first time I encounter, for example, here, this example here is telling me that the value of 4 was encountered twice, right? So the first time I find a 4, I set the value to 1. The else statement is if it's already in there and we increase it by 1. So if it's already been encountered, we'll increase it by 1. If it's not encountered, that means it's the first time we've seen it, and we should set it to 1. Right? All this making sense so far? All right. And something very similar to that we want to do for our suits, right? So we'll say if the suit is in, or let's say not in first, not in suit counts. I want to say suit counts, and then I'm going to set the suit as a key, and I'm going to set it to 1. But if it's already in there, I need to increase the count by 1. And before I move forward, I want to make sure this is working. So let me go ahead and call this function where I say print, or let me just call the function determine hand ranking. I'm going to pass in hand 1. And within this function, I'm going to print out suit counts, and I'm going to print out value counts. Right? This is hand 1, the one that we're passing within this function. And let's see what it gives us. And there you go. Right? The suit counts, it counted how many of the suits are in there. It's telling me that it encountered the heart, and it encountered it 5 times, which is true, right? This is a royal flush example. That means they're all the same suits, and there's 5 of them. And then for the value counts, we encountered a 10 once, the jack once, the queen once, king once, and ace once, right? And now we were able to separate that hand into some kind of way that we can now determine what type of possible combination we have. And this comes in hand because we need to figure out how many times the suit appears. If it's a royal flush, we know that all of the cards in this card combination need to be the exact same suit. So to check if it's a royal flush, the easiest way to figure out and eliminate any other possibility is check, hey, is every single card the same suit? Do I only have one key in the suit counts? And is that key a value of 5? If so, that's going to tell me right off the bat, right, that this is either a royal flush or a straight flush. And that automatically eliminates everything else, right? Because everything else, look at it. It's a combination of 3 of a kind and a pair in the same hand, right? So 3 of a kind, we have the ace that appears 3 times, and the pair is a number that appears twice. But the suit doesn't matter, right? The flush is 5 cards of the same suit in any order. So this didn't eliminate everything exactly. It left us with royal flush, straight flush, and a flush. So these were the 3 possibilities. Knowing that if all the suits are the same, we know there's 3 possible solutions to this one, right? All 3 flushes. The straight is 5 cards of any suit. Well, this automatically is not a straight, right? Because it has the suit of all 5. Actually, it might. No, it wouldn't be a flush because it's of different suits, right? And so on and so forth, right? 2 different pairs in the same hand. We have 2 different pairs, but notice that the suit doesn't really matter. That's not what they're looking for. But by having this formatted in this way, we can kind of start making combinations, right? And now we could do a bunch of if-else statements, but what if we make specific functions? Like, what if we made a function that's define is royal flush? We'll put pass. What we do define is straight flush. And I put pass for now to not get an issue. What do we do? Define is flush. Define is straight. And so on and so forth, right? Because all of these different combinations have a specific way of how to be determined. Instead of adding all that code into one function, what's cool about functions is that you're able to isolate your code, make it clean, and you don't clutter it all within here. And we're going to do the royal flush first. And this will be part of my example. After we do the royal flush, I'm going to split you guys up back into your teams. And hopefully this gets the ball rolling for the remainder of class. So with the knowledge you guys have now, what should my royal flush be doing? How can I work this function to determine if this hand is a royal flush? Talk to me.
If you have a 10, jack, queen, king, and ace of the same suit.
There we go, right? So if they're all the same suit, and if they're a 10, jack, queen, king, or an ace, those are the highest value cards, right? And we already have a constant of that. We know that the 10, jack, queen, k, and a are these are all in order. We could probably use this constant here to check what our current hand is and see if they are in the index of, I believe this is index 8 and higher. If these cards here are all of index 8 or higher, that's going to tell me that more than likely they're probably going to be a royal flush. After I check if they're of the same of this index of or higher, then I can check if they're all the same suit. Therefore, figuring out if it's a royal flush or not, right? So let's do that. Well, first let's check if they're the same suits, right? If they're not the same suit, they're not going to be a royal flush or any flush to begin with. So we'll say if and we're gonna need some arguments in here. We're gonna have to pass some stuff into our function so we have access to the data. Well, where do we have the suits? It's suit counts. So we need to pass in suit counts, and we need to pass in value count into our function. So we'll say suits, comma, card values, right? Suits and card values. So whenever I run this function, I'm going to pass in the dictionary suit counts, and I'm going to pass in the dictionary of value counts. And then with these values inside my function, I'm going to check them. If suits, how can I check if the value of 5 is within this dictionary? There's two ways of doing this. I could check if the length is 1. That means there's only one item in here, which therefore telling me that there's only one suit that's been encountered, right? Because if there was other suits like a spade or a club, then this will definitely have more key value pairs. So I can check if the length of my dictionary is greater than 1, or I can also say if 5 in suits dot values, right? Because this returns all the values within my dictionary. If the 5's in there, that means that we also know that the 5 cards were all the same suit, right? So if 5 in suit values, I can continue moving on, right? I'll just put path here. If they're not the same value, I want to return false, right? Because if they're not the same value, this is not a royal flush. So right off the bat, the moment I run this function, this should let me know that it is false, right? But if they are the same value, the next step to figuring out if this is a royal flush, right, is checking if they're the 10, the jack, the queen, the king, or the ace. So I want to loop through these right here and check if they are the 10, the J, the Q, the K, or the A, right? The card values. So I'm going to say if 5 is in suit stop values, I want to loop through my cards for card and card values. And now I got to check whether the 10, the jack, or the queen, or the king, or ace are actually the correct ones that are making a royal flush, right? So a royal flush is everything from the 10 and up. This is index 8, I believe. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So I want to check for card and card values. If card is equal to let's do dot keys just to specify that we're checking the keys, right? We're checking this. If the card is equal to values, how do we do this? How can we check? How do we do this? If value what do you guys think? If card is equal to values dot range, I don't know if range is what do you say? If card in, right? What do we say if it's in card values, or I'm sorry, values from index 8 into the right. Right? So if the T is inside of this values list, starting at index 8 into the right, I think we can do that, right? If card in values from index 8 to the right, then we want to continue, right? else return false. Now, if this makes it through the entirety of this for loop, at the end of it, we need to return true, because that means that at no point did it stop because it did not exist in there. Now, let's try this out. Where is my function? Okay, here we go. Let's go ahead and print is royal flush. We'll pass in suit counts and value counts and run this. And there we go. We get true. But just to make sure that we didn't mess this up, let's change this to an S, right? The queen of spades. And we get false, right? Because it wasn't the same suit. Let's go ahead and change this back. But instead of a 10, let's add a 7. And we get false again, right? So this function here is working. It made sure that they're all the same suit. We then checked if the card we have is actually from index 8 or higher. And then after we're done with checking every single card, we return true. If at any point we encountered a card that was not from index 8 or onwards, we return false, right? But that didn't happen. We continued because we kept finding the card within this index range. And once this for loop finished, we return true, right? Do I have any questions on how I was able to accomplish this?
Can you leave this up for a few minutes there, Roger?
I definitely will leave it out. Hopefully this helps. I don't know if this is too zoomed out. I'm gonna go ahead. I'm gonna copy this real quick, and I'm going to add it into the Slack channel instead. But I will still keep it out. I don't know if you can see all of it from here. I'll add it to the Slack channel.
Thanks.
No problem. Any other questions, guys? It is in the Slack channel, so definitely pull it down. Michelle, are you in the Slack channel?
I am in a Slack channel. I'm just in general though.
Okay. Let me see if I can find you. Michelle Burris. I added you in there. Can you see what's in the Slack channel that's been posted?
Yep, I got it.
Okay. I'm gonna go ahead and stop sharing. Use what we have in the Slack channel, and the reason I'm gonna stop sharing is I'm gonna break you back into your rooms. But use that code as a guide to kind of get you going. Because I saw some crazy stuff, a bunch of if-else statements and whatnot. But hopefully this makes a little bit more sense of how you would approach this. Yeah, Nicholas. And that's okay, right? That was a nice try. But as you guys saw here, there is a much more efficient way of doing this using the tools that you have been given. Let me go ahead and open up the breakout rooms again. I'm going to move Carlos into Jamar's and Morty's room because we lost somebody in the attempt of all that. And I'm gonna go ahead and open up the rooms. We're gonna come back at 8:40. And then I want to see if anyone was able to solve any other combination, and then we'll call it there. I'm gonna go ahead and open up the rooms. I'll see you guys in 40 minutes. All right, welcome back, everybody. So we just finished off working on the poker. We're returning from our breakout rooms. First on the list is gonna be Jamar, Carlos, and I believe it was Morty. They ran into an issue, and they're gonna go ahead and debug it for us here. We'll talk through their code and their thought process. Go ahead and share, Jamar or Carlos, whoever was working on it.
Go ahead, Carlos.
Sure. Um, can you see my screen, Roger?
Yes, I can.
So, well, basically, we were trying to figure out like why we're just getting this 0 zeros and we weren't getting anything else. So we were thinking there's either something here within the print suits count. So
What
we
I wanted-
moved. Sorry, go ahead, Jamar.
Oh no, I was about to say what we tried to do was move the print up some to see well if we can get this part of the code to run. Maybe that's not the error and keep going down. But we put the print up under
Up here.
where he is right there, and it still didn't work. Still got the 0.0 seconds.
All right, I'm gonna stop you here real quick. Scroll down. Where you're calling determine hand ranking, it's indented. It's inside the function itself. I need you to unindent it. So scroll
Where?
to the very bottom. Right there. Determine hand ranking. Backspace. Run it. Okay, now scroll down.
141.
We are getting an index issue.
Yeah, there's a lot of stuff wrong here.
List index out of range. Okay. We're getting an issue on line 36 where suit is equal to card of index 1. Scroll up. It's saying that the list is out of index. So whatever you're passing in here, it can't grab index 1 because it's out of index. Okay. Here on the AH at the very end of your hand 1, you see the AH?
Mm-hmm.
Yeah. Is that meant to be like that?
The ace of
Or was
hearts.
that typo? So what this is telling me, this is a string called AH bracket. That is one string right there.
Oh.
So KH needs to change.
Okay. But what about the AH? What does that look like? What's in that string?
Jesus. Oh, come on, Roger. What is this? Okay, here
Okay.
we go. Wait, hold on. What is this thing?
Okay, because you have another bracket in right after TH.
So we need another one.
No, you need to get rid of the bracket right after TH.
Yeah, we were getting an error if we got rid of it. Here we go. Okay, that's
Mhm.
working now. Huh. All right, so we were missing that there.
Yeah, it was the list wasn't properly being made. Go ahead and run it again. Scroll down. There you go.
Oh man.
Oh wow.
Jesus. You found
Ooh,
that
some-
quickly? It's the damn dot.
It's syntax, right? So it's it's grammar, right? It won't know exactly what you're trying to ask from it. Okay. Well,
Yeah. Thank you, Roger. I wouldn't have saw that unless it hit me in the
it's
head.
okay. All right. Well, good stuff, guys. I'm assuming that's all. You guys didn't get anything else besides the royal flush. Is that correct?
correct.
All right. Let's go ahead and see what the other team was able to concoct. Can I see Nick, Michelle, and Esperanza? Do you guys have something to demonstrate today?
Yeah, I can pull up my screen.
Awesome.
Project. Okay. I can't really see past. Okay. So we hadn't gotten to generating the card hands yet. We were going to based on the last session when we started this, but the royal flush. So after we went through that, so what I think we already went through that, right? Like we already did. So we had
Mhm.
5 cards and
Yep.
and they all were matching suits. So then the straight flush, we don't really, we just need 5 cards in a row. So this one's, we did a bunch of if else statements. Basically, if these cards all were in this value parameter, then it would return true. So and the other thing is it has to all be in the same suit. So that negates like the ability of having multiple ones or twos or threes or fours. So for example, like if we had 2, 5, 4, 3, and 6, and then incrementing, so there could be any combination within these, it would return true. And let's see, they all have to be in the same suit, of course. And then that one would be true. So that's our
Okay.
straight flush print. That's one right, that one right there. And then, so 4 of a kind, 4 matching values in the hand. So if 4 cards all are the same value, then it returns true. So I'm trying to do that. So yeah, suit doesn't matter. And they're all 5s. And there's 4 of them, so we'll leave that one as a 2. 4 cards in a value in a hand. And then that one's true. And then 3 of a kind in a pair. So this one, if you do 2 in card values and then you do an and statement and 3 in card values, so 2 are matching in value and 3 are matching in value, that'll return true. And then the last one we got to was the flush. So all 5 cards are the same suit. It doesn't matter what the value is, it just matters that they're all in the same suit. So 2, 5. And this one is the flush statement. So we're calling on suits and the suit counts, and that returns true.
What else is returning true in here?
Ooh. So flush is returning true and straight flush is returning true.
Yeah, why is that?
That's because straight flush is 5 suits all in the same 5 cards in the same suit. And let's see. 2, 5, 6, 7. But this one's calling an A or an ace. I don't know.
Yeah, that I was about to tell you, I was about to break your code with this because that's
Yeah,
exactly
we
what your code is
didn't do
doing.
well.
No, I mean you
Okay.
made great progress with the little time that you guys have left. This is great. The only thing that you're failing to take into account are for the edge cases. For example, this function here is straight flush. If you ran this function on technically a hand combination that's a royal flush, it'll still say true. But if it's a royal flush and it's also a straight flush, which one should it
Should be
work on?
considered
A royal flush, right? Because this right here, you're checking if you're still checking for the index of 8 and to the right, which is gonna pass, right? Just like the royal flushes, we're checking from 8 to the right. The straight flush is doing the same thing too. So both of these are going to be true, and that's where you're going to get some issues. So you have to take into account the possibilities of different functions getting you the same result. So you have to ensure that for a straight flush, if it's going to be from index 8 and up, that needs to be considered a royal flush. And it's going to look something like this. I'm going to put it in the chat. right?
Should we have just used return true rather than continue, maybe?
Yes and no. Look at the code I added on the chat, right? I sorted the cards from greatest to highest, right? I check if the value in the cards are at any point higher than 8 or less. Depending if they're higher or less, then I'm either going to return false or continue. If the value is greater than 8, right, I'm going to break this statement because obviously, I'm sorry, if the value is less than 8, then I'm going to break because I don't need to continue. But if for whatever reason all my cards are higher than 8, that means it's probably going to be a royal flush, right? If not, then I'm going to continue doing my check. And then I do a for I in range loop here where I'm checking if the card is a continuation of the previous card. You see there, if sorted values I does not equal sorted values I minus 1, I'm checking if they're back to each other. So there is a much efficient way of doing it. But this is a really good start, right? It got you thinking. You were able to kind of figure out what you're looking for, and at the same time, you're reaching some kind of output, right? But this is good. I'm gonna stop you here. If you don't mind, stop sharing. This is gonna conclude today's class, actually. But good job, both teams. You guys did great. I want to thank every single one of you guys for making it all the way to the end of the Got It application program. I'm going to go ahead and stop the recording now.